Hi. The topic today is Angular IV, or the next big thing in Angular. We saw Brad in the keynote talking about IV. And the truth is that I don't know when it's going to be official or default, but probably next year for Angular 8. And I know that the Angular team has worked on Angular IV for a long time. So it's going to be a really big change in Angular. So my name is Stanimira Vlaeva, in short just Mira, you can call me Mira, and I'm a developer at NativeScript. I live in Bulgaria, which is quite far away from here, and I work on the Angular integration, the code sharing story. Also, I do some performance stuff with Webpack mostly. And today we're not going to be talking about NativeScript, but I have a workshop tomorrow at 3 p.m. So if you want to learn more about code sharing between web and mobile, you can come and watch the workshop. It's going to be hands-on, so you can bring your own laptops, and we're going to build some cool stuff. Cool. About Ivy. As I said, it is not finished yet. It is not really official. You can already use it under some experimental flag with the CLI. But it is not official, it's not production ready, you shouldn't ship your apps with Ivy. So with all that said, we're going to focus on what Ivy will bring to us as developers. It's not going to be a deep dive in how Ivy is implemented, but mostly what features it will unlock. Actually, Ivy is the third generation of Angular renderers. When Angular 2 was released in 2016, we had this set of instructions. Well, actually, we weren't writing that code, but when our components were compiled, this is what is the code that was generated. And yeah, you obviously can't read the code. Actually, what I'm trying to show here is just the size of the generated code. So as you can see, the generated code is pretty big. It's huge, which means big bundle size, which means bigger applications and slow load time. So the next version of Angular, the next major version, Angular 4, introduced the View engine. It's the second generation of Angular renderers. And you can see that the generated code is much smaller. But it still has its problems, as we're going to see later. Ivy, which is going to be the next renderer thing that we're going to talk about today, as you can see, generates really short instructions from our component. And these instructions are really declarative. If you have time, we're going to take a look at the instructions, and we're going to see that it's really clear what is happening, how the renderer builds our component into HTML. And the other important thing here, as I said, I'm working on the Angular integration in NativeScript. Part of my job when I started was to migrate from Angular 2 to Angular 4. And NativeScript is an interesting case because it's kind of a framework which builds on top of Angular. So we have our own renderer. We don't render DOM elements. Instead, we render native mobile components. And Angular provides that abstraction, so we can build our own renderer on top of the Angular renderer. And to be honest, it was really hard for me to migrate from the Angular 2 to the Angular 4 renderer. There was not a lot of documentation at the time. And I could kind of understand the generated codes, but still there are some weird parts of it that I didn't really know why they were there. So it all turned out well. We managed to migrate to Angular 4. It was great. It was faster. And later, the Angular team started working on Ivy. And to be honest, Ivy is really cool because you can fully understand the generated code. It's much different from the first version. So we have come a long part from this in the left to the right. Cool. So we're going to talk about three things, the three main parts that I think are most important for us as Angular developers. These are features that will be unlocked when Ivy ships. And the first thing is locality. Okay. What happens now when our compiler tries to compile our application is that it needs the whole global context in order to compile a single component. And what will happen with Ivy is that we can use only the data in the component class and the component metadata in order to compile our component. We don't need to know anything about the outside world. Again, this is an oversimplification because, of course, one component can depend on other components. So let's imagine that we have a component A which uses component B. So it's kind of a parent of B. Of course, if B changes, we may have to recompile A. But here's the important part. When do we know if we have to recompile the parent component? Well, only if some part of the public API of the child component changes. So if you change something private in the child component, our parent component, or whoever is using our component, shouldn't care about that. We only need to recompile the other parents if the public interface changes. So we're talking about locality. We're not compiling exactly one file at a time. We may have to compile more files. But again, we don't need the whole global context. We only need to know what is in the component and its children. Why is that important for us? Because if we change one file, we only have to recompile a really small chunk of our application. We don't have to run a static analysis of the whole app, which is slow. And therefore, compiling just the changed part will lead to a lot faster incremental build. The other interesting thing is that this will allow us to get rid of the metadata JSON files. These are files which are shipped with the Angular libraries in NPM, and they provide the information in the component metadatas. So we have our TypeScript file. Can you hear me? Which have some class and a decorator with some metadata for that class. When we transfer that TypeScript file to JavaScript, the metadata is gone. The decorator is not there. The information from the decorator moves to the metadata JSON. But with Ivy, we won't need that metadata JSON files. Actually, the information from the decorator will be stored in the JavaScript file itself. And also a small part of it will be stored in the TypeScript definitions file. This will allow us, in the end, to ship compiled, ahead of time compiled libraries to NPM. And I'm not going to focus on that, but there is a link there. So when you get the slides, you can go and read about the new architecture of the Angular compiler. So the Angular compiler should also migrate in order to support Ivy code. All right. The second thing I'm going to talk about is tree shaking. First, what is tree shaking, of course? In short, it's about eliminating unused code. You can see here we have one file, first TS, which exports two variables. And we have a second file, which imports only the first variable. And let's imagine that that's our whole project, right? And clearly, the second export const bar, is not used anywhere in the app. There are these tools out there which perform tree shaking or dead code elimination, or it's called, it has different terms. We stick to tree shaking. The idea is that these tools can identify that the second export is not used, and they can just remove it from our code. And why is that important? Because let's say that we have a big library, for example, ArcGIS. I don't know how many operators are there in ArcGIS. There are quite a lot. And in most of my apps, I'm usually using map and maybe 3 for other operators. So what I mean is that I only need these 5, let's say, operators from ArcGIS. I don't need the whole library ending up in my bundle because it's huge and I'm not using a really big part of it. So that is what tree shaking will do for me. It will eliminate all the code that I'm not using. So I can actually end up only with the code that I'm using in my application. And another important point about tree shaking is that it does a static analysis. It doesn't run the code. Let's see a simple example again. We have a single export. Then we're importing that thing in another file. And clearly, that console walk here will never be executed. So actually, foo is never used in our app. But the tree shaking tools doesn't know that. They can't execute the code, and they only perform a static analysis. They see that foo is imported, therefore someone might use it. Therefore, the export const foo will still be in our bundle. All right. With that said, Ivy is really great at compiling or rendering tree shakeable code. With Ivy, Angular will be able to tree shake a whole bunch of its features. Like if we're not using dependency injection in our apps, it won't be included in our final bundle. The same goes for translations, animations, queries, and a whole bunch of other Angular features. In the end, this means that we have a really small Hello World app. The smallest app where we don't have any of the actual Angular features can be tree-shaked, can tree-shake all of these features, and instead we have a really small bundle which is less than 5 kilobytes. Why should we care about that? I have never written a Hello World app for production, right? Our apps usually use dependency injection. They may or may not have international translations, whatever. They have all these features in Angular. Should we care about tree shaking all the essential parts of Angular? Well, first of all, this allows the Angular platform to be extended quite a lot. So in the future, if the Angular team decides to put 5 new features and we decide to upgrade our app, we're not going to get all these features if you're not actually using them. Also, if it's extended with a lot of new features and we selectively start using some of them, we're just going to get the feature we're using. That's pretty cool. And the other reason is Angular Elements. Brad mentioned in the keynote Angular Elements. It's a way to ship custom elements which work in any JavaScript app on the web and are not really tied to Angular, but it's kind of a way to pack a really small Angular module or a whole application and distribute that. And in some Angular element, we may not need dependency injection. It's totally possible. We may not need the whole bunch of Angular features out there. And this is cool because this leads to small elements which can be distributed across everywhere. Cool. The last part that I'm going to talk about is debugging. So Ivy will bring a much better debugging experience to us. And I'm actually not going to talk, but I'm just going to show some stuff here. Hopefully it will work. So here I have a really simple Angular Hello World application that was created by the Angular CLI. And the important part is that it's compiled with Ivy. So it's still experimental. It is available to use with Angular 6 and 7. Okay, the first cool thing I want to show you is something called ng. Obviously, and I'm not talking about Angular, but the global ng variable. What we can do with that, first let me select some elements in the code. I'm going to select the uproot element. And because I selected it, it is available in that variable here. As you can see, that is just the DOM element. And the ng variable has a pretty cool method called getComponent. And we can provide any HTML element. And what we get is the actual component, the compiled component. And here we can see quite a lot of things like the variables in the component, how it was compiled, and something called ngComponent definition, which is the compiled component. This is how it's going to look in Ivy. And it has quite a lot of things. It's really powerful if you want to deep dive in the code that Ivy produces. And I recommend that you can just go ahead and try it. Cool. So what's interesting we can do to our app? I propose that we can just break it for a change. I'm going to go to my app component template. And here I'm going to add a click listener. And I will try to execute some function that doesn't exist. As you can imagine, that we will break our application. Actually, it's not going to break it. We're just going to see some error. So when I click on the title, I see that error here. Context random is not a function. Cool. So why is that important? First, if you ever tried to debug Angular code and Angular errors, the stack trace usually doesn't look like that. It's quite longer. I usually have no idea what is happening. And with Ivy, we have a lot shorter stack traces, which are easier to grasp. And in the first thing, the first line, we see here app component. That is the component where the error happened. In the template, there is a click listener on the H1 element. And this is where the error happened. So we already know where's the problem. And the other cool thing about Ivy is that you can actually debug the template exactly. So I didn't manage to make that work with the Angular CLI. Either it is not supported by the Angular CLI yet, or I did something wrong. I don't know what it is. But if you go here with Ivy later, we should be able to see the template itself and debug that. All right, so that is about debugging. And now I'm going to show you what else is different in an application. First, if we take a look at our Bootstrap code, the main.ts file, this is how the old Bootstrap logic looks like. So we're importing some root module, and then we're bootstrapping it with Platform Browser Dynamic. And this is how the rendering process, the bootstrapping process, sorry, looks like in Ivy. We're importing our root component, not the module, but the component. And then we're just calling render component. And this is how we bootstrap our application. Cool. Another thing that you should do to enable Ivy is go to your root module. And here, usually you have a browser module import. You should get rid of it just to make Ivy works. And the third migration step is actually the TypeScript configuration. So as I said, Ivy is experimental. It doesn't run by default. So we got to add an Angular compiler option to our TypeScript configuration, which is called enable Ivy. And then we need to provide that value. Awesome. So let me go back to my slides. And I think I'm almost finished. And this is my favorite part. As I said, I spent quite a lot of time migrating from Angular 2 to Angular 4, the new renderer. And my favorite part is that Ivy is actually backwards compatible. And I won't have to hopefully do any work to migrate NativeScript to, I hope. Nice, right? And this is how you can create a new Ivy project with the Angular CLI. And just go ahead and play with it. It's really easy. Time to see some code, but you can go ahead and inspect your bundle and see how does that look like. Okay, thank you.